All right, up here. On these, this is what we're going to do this chapter, and you're going to have to listen closely to this chapter because we are going to squeeze it in before Christmas break, and it's going to be done. So if I have to do 6 sections in one day, Austin, and you're just lost, I feel bad, but that's what we're going to do. So watch closely. Some of this stuff you should already know. Some of it might be a little new, but you can probably figure it out. What appears to be true about the two triangles? Look like they're congruent to each other. That's all you had to put was congruent. Angle A, congruent to which angle? Angle M. Very good. Both triangles are what kind of triangles? This is something we're going to learn today. There's probably a poster around the room somewhere that you could have looked at and figured this out. Isosceles.
Yeah, I spelled it wrong.
I don't care about spelling. That's English class. That's how you spell it, but however you spell it, as long as I know it. It's supposed to say isosceles, good enough. If the measure of angle B is 32 degrees, then the measure of angle R should be what? 32 degrees. They match up. If these two triangles are congruent, like you said, number 1, then angle B and angle R match up to each other. They got to be congruent. They got to be the same. Segment AB is right here, is 12 centimeters. Then what other segment has to be 12 centimeters? MR. RM I would accept also. It means same thing. And again, that's just matching the two triangles up. And this is part of what we're going to do here in the next couple of days. What would you have to do to get this triangle to match up to that triangle? Like a rotation. That's what we did last chapter. This one here, very, very important. So Curtis is going to focus back up here for a second so he understands this. Because when we start doing this chapter, and there's going to be a lot of 2-column proofs in this chapter, and nobody likes them, this is one step that Curtis can get right every single time and get that point. All right? Triangle, CBA. CBA. So they went around the triangle that way. C, from C to B to A. Is congruent to triangle. How's the other triangle going to match up? What's C match up to in the other triangle? C matches up to T. B matches up to R. And A matches up to M. You got to make sure you name them in the correct order so that they match up. All right? Lay it on the chair. Everybody think they can handle all that? Were you do all right on that little? I'll probably count that as like a homework assignment. All right, with all the stuff that got handed back. Number 1, everything that got handed back was a quiz or a test, so it's got to go where? In your quiz or test section. Now, before you do that, the Chapter 4 test. I don't want it stuck in there yet because I want to go over it real quick. So have it out, looking at it. Chapter 4 test. So let's figure out why. That's what we're getting ready to do right now. So then during the intervention,
it's not like I'm going to use it.
I hope someday, Curtis, that you do use some of this stuff that you learn here, but it's not an argument I'm prepared to have with you first day back. Our whole purpose here is to make you the best Curtis Barnhart you can possibly be.
I think the purpose of school is to give me the worst anxiety I've ever had in my life.
So which questions, Lexi? Before break, I said I was going to get tired of saying it. One of the multiple choice says graph the polygon in its image and then rotate it 90 degrees counterclockwise. They give you a shape. Looks something like this. I'm just going to graph this real quick. You can try to find it on your paper if you want. The original shape looks something like this. Then they want you to rotate it 90 degrees counterclockwise. Which way is counterclockwise going to be? This way?
Yeah.
So we're going to rotate it this way. If we go 90 degrees, if Curtis takes his paper and he finds this problem, ever get it open. And he rotates his paper 90 degrees counterclockwise. That's that way, right? Look at the original shape, Curtis. See where it ended up at in relationship to your X and Y? So which one of those ended up in that space? Like that one right there, right? So it should have ended up down here somewhere. Is that one of the answers?
Wait, you said C was answer?
If whichever one ended up.
Yeah.
I got C. I got it right.
Well, I put down D and you made it wrong.
Let's not go through this. First day back. Why? Tell them all, Kenneth, why? What? No, why did you get it right and put that letter and somebody else got it wrong?
It was a different test.
That's why I'm not explaining. I'm saying the shape went from here, should be right there, so look at the picture. Other questions? Trying to think which ones I remember everybody missing the most of. The train one, and it's probably Evan, because he's always against everything I say.
I got it right.
Somebody brought up the point that if the train pulls in here and you turn it 180 degrees, which way is the train going to go out?
The other way.
And I said this way, but some people brought up the fact that if you pull the train in there and it turns all the way around, let's say the train's pulling in right like this, you turn that circle 180 degrees, it's going to be facing back out the same way, right? So I gave you, if you put down that one or the other one, I can't remember what the problem actually said, but there was two different answers that I accepted. So I accepted the one where somebody was thinking, okay, the train's going to be facing this way, so it's going to be heading out that way, or the train is going to end up over here on this side. I accepted either one. Which question did you say? Another of the multiple choice. They gave you this, and yeah, this one that a lot of people missed. They had a triangle here, and then they had a triangle here, and they said, what did you do to that triangle? Well, if you counted the spaces, it looks like you went, let's see, down 2 and left 1, right? And that's probably what Bree messed up. One of the multiple choices that's got both triangles on there, and it asked you what it did. So it goes X, Y, goes to X something, Y something. Now the bad thing with this one, you guys probably got a jiffing because all my other classes, I made sure after your class that I said, make sure you read the graphs, even though I've said it a few times. Make sure you look at the graphs carefully. How much does each one of those boxes count? 2. So if it went left 1 box, it actually went left 2 spaces, right? If it went down 2 boxes, then it actually went down 4 spaces.
How about the first answer, scratch
So you gotta be careful, and again, all my other classes, once I seen the test, I was thinking, I better tell them, watch the graphs, because some of the graphs, they go by twos. Other questions?
Two.
This is gonna be a long time, because I'm gonna keep waking you up and waking you up, and after a while, I'll probably lay a detention on your desk and wake you up so you can see it. Don't care about that? Probably I'll just take a picture of you, so that way I got some kind of protection for myself. On this one, it says graph the quadrilateral. This is the one that's got the scale factor of 1/5. So find that on your test, the one that's got the scale factor of 1/5. Look through there real quick. And I'm not going to bother to graph them. What's the first point? -5, 5. What's the next point? What was this one? A? B is, C was, and D was. And they told us that our K, our scale factor, was 1/5. All right? A lot of you, and I tell Bree this every time before we graph anything, Bree, what do you have to remember when you're graphing this point? That goes left and right, up and down. I may have written on your test there, because a lot of people this time graphing them backwards, going up or down first, then left or right. Make sure you're not making that mistake. And the thing that confused me is a lot of people doing it, but they do it like on this point, then on the rest of them they would do it normal. So I'm not sure why one time you do it up or down first, then left or right, and then the rest of them you did it the correct way. All you got to do with this scale factor, so all Curtis has got to do right here with this scale factor, take it and multiply it times all those numbers, each one. So A prime, what's 1/5 times -5? What's a fifth, Caleb, of -5? Don't say I don't know, you know I won't accept that. So, you don't need your calculator. What's a fifth of 5? You got
one.
All right, and if it's a negative, then it's what? -1.
That's not 16, my favorite.
I know, that's why, sorry, I did put the number up here, didn't I? I shouldn't have ever did that. We gotta go back to this
okay.
again.
No, I see it. Right.
What's 1/5 times 5? Caleb, what's 1/5 times 5? 1. Positive 1 this time, right? B prime. So Bree, what's 1/5 times 0? 0. And Bree, what's 1/5 times -5? Curtis, or Caleb already did it for you. -1. That's B prime. C prime. Lexi, what's 1/5 times 10? What's a fifth of 10? 2. What's a fifth of 0? D prime. Chloe, what's a fifth of 5? Chloe, what's a fifth of 5? Now we have all these new points. Could we graph them? And that's what we had to do on there. We had to graph the original, then graph the other one. I think it ended up looking something like, I don't know, something like that was the original. And then what would the image be? What would it look like? Be a lot smaller, something like that. I can't remember exactly what it looked like, but it's something. Is it slanted the other way? Other questions? Sort of figure out what you missed and why you missed it. If you Some of them, I think,
I don't know.
just because people were being a little lazy there right before break. Didn't wanna do that work on that Friday. Number 2, which is the one where you have the big triangle, then the little triangle. No easy way to do this when you're going backwards, and that's why a lot of people also missed this one where you had to explain the transformation. Because there's no easy way to do it when you're going backwards. You just have to really, really think it through. The first thing, if I know I'm going from triangle WXY, which is the big triangle, to triangle ABC, which is the little triangle, am I getting bigger or smaller? Smaller. So what's my scale factor gotta be?
1/3.
Okay, it's gotta be the fraction one, right? So it's gotta be one of the two 1/3. And then from there, you just have to make the decision, which one of those two 1/3 is it? You gotta decide whether,
Yeah, that's why.
you just have to sort of really think it through in there. Other questions? Guarantee you'll see some more of these questions in a week or so, 2 weeks, whenever semester exams are, Caleb, so. 14?
Well, I guess we go with that.
Does the original triangle look like this? Is that about right? And P is, about here? That pretty close? What's this point? B? C? All you're gonna do, bounce each point off of it. We want a 45-degree angle, that's what it said. It said 45 degrees clockwise. Clockwise is that direction. 45 degrees is about half a 90, so we want about that angle. So we're gonna bounce A off of it. And it's gonna come down here about 45 degrees. Something about like that, just measure it, didn't have to be perfect. About that far, so A prime, gonna end up somewhere about in there. Bounce B off of it, and again, my picture might not look exactly like yours because it's not set up the same, right? Because I didn't copy it. Same, 45 degrees, somewhere about in there. B is about that far, so B prime, somewhere about in there. C, 45 degrees. I might want a little wide on that one. Right about there, about that far, about that far. C prime, connect them. New shape should have looked something about like that. 3 things I counted on that one. Number 1, did you turn it the correct way? Did I turn mine clockwise? Yeah. Number 2, was it about the right amount of rotation? Does it look like it went about 45 degrees? Yeah, maybe close. And number 3, does the new shape look about like the original shape? Alright. Make sure all that stuff gets into your binder where it belongs, in the tests and quizzes section. My friend sitting up front here says I'm gonna fail everything anyway. That's what I hear out of him every time. Can he make sure then on his binder that he gets a good grade?
Yeah, you get 100.
Does he have to know any of this math to be able to do well on this binder? No.
We do watch that stuff.
Yeah, we're going to. I don't know. I might skip it this time.
Yeah, it'll go.
Just skip them.
Yeah.
We'll see. We'll see how you're actually doing all the rest of the stuff, Caleb. So if I keep hearing, oh no.
I just can't get put on the spot like that.
And Curtis is up
Yeah,
here
give me
going,
time.
what's a man gonna feel anyway? What's a man gonna feel anyway? If I keep hearing those two things, then yeah, we're probably gonna write them down.
Curtis, I seen you the other day.
What's wrong?
Where?
All right, go ahead and copy this down. Set of notes. Chapter 5, triangles. Write quickly because we're going to move extremely quickly. So you got about 10 seconds to write this slide before I change it.
What?
9,
That was my birthday.
8, let's go, Curtis.
That wasn't even-
7, 6. We're writing down notes. Everybody should be listening, not talking.
Sorry.
I want you to be sorry. I want you said you're going to fail everything else. Well, this is the one thing we just decided that you could actually do well on. So right. Right. Ooh. Otherwise, I got to get back a hold of mom and say, yeah, you know what? Ooh, you probably ought to stay after school.
Well, I told my mom I'm probably gonna fail anyway, so it doesn't matter.
Your mom's like me. She wants to give you all the opportunities she can. So.
Okay.
If you pass Miss Brown,
Yeah.
If you pass Miss Brown, that doesn't
Come on,
mean you're
Ryan.
pass this.
wait,
She gave you all the answers.
Yeah,
so
you did. For
wait,
example,
she didn't teach you though. You learned yourself.
No, I didn't.
I know.
She definitely didn't teach me.
Well, that's because you're smart in general, so.
Keep writing. Let's go. Curtis,
I take it.
I ain't got nothing to do with it, Curtis. Everybody is born with the same size brain, my friend. It's not.
Nah,
It's-
definitely
Except
not.
to say, okay,
You just gotta decide what you want to do with it.
well, it's not funny. It's true. Some people have like huge brains, like they're born.
No, they don't.
Yeah. She like has like that big. Like, it's huge.
That ain't got nothing to do with his brain. His brain is basically the same size. Everybody in the world's got the same size brain. Come on, Curtis, right?
I'll make a number with that.
All right. You need to
You
Google
don't
this.
use it.
Hey,
I gotta write
Siri.
notes.
Hey Siri.
Should write some of them. All right, chapter 5, triangles. Be able to classify triangles. I think we did a little bit of classifying triangles at the start of the year. You got to be able to name them according to their sides or their angles. It's one of the things we're going to go over. That should be pretty easy. You already knew what an isosceles triangle was. That's one of the classifications. Be able to find angle measures. We're going to go over a bunch of rules about triangles. Triangles are called rigid figures. And the reason they're called rigid figures is because there's a lot of rules that triangles are set in. They can't do anything else but use these rules. Curtis may never ever use any of this. That's what he said, but I'm hoping when he gets out, he can actually use, especially the stuff about triangles, because in everyday life, use a lot of this. Now, there's a lot of people who Bree's up here going, I'll never use any of it. She might be right, because my wife doesn't ever use any of it either, because she counts on me to use it to figure out how to build a deck on the back of our house, figure out how the property lines are on our house, and how we can split off.
You can hire
You can, that's right. And I hope that you have a job that pays you about $6 million a year, so you can hire all those people to do
That's the
everything
thing I
for you,
thought for.
because otherwise, go home and ask your folks, hiring everybody to do everything isn't much fun.
Yeah, I know, but then you just don't do it.
Sometimes there's things that you have to do.
You ain't gotta build a deck.
That's true, you don't have to build a deck.
To be good friends with
Wanted
the
to.
county, you know, you gotta be
Where you
good
gonna
friends
get
with
the
somebody who
money
can do all
Exactly.
that.
See, you gotta know somebody that knows somebody.
You don't have to live in a house.
I know,
You know,
yeah.
there's
big cardboard boxes.
there's
I'll
a
just call Lexi if I ever need her to buy a horse. I haven't done any talking.
be able to find the angles.
You don't know any of that.
Lot of rules with triangles. Shh, Curtis, Evan. Shh. Be able to find the angle measures using those rules. Use and understand properties of equilateral and isosceles triangle. What is an isosceles triangle? You guys said that those triangles earlier. Was it?
Two sides.
Two sides are congruent. What do you think equilateral is then?
They already.
All the sides are equal. All right, write this down. Yes, Curtis, you have to write this
I
down.
was gonna.
Way to classify triangles, two different ways. On a test, when I say classify this triangle, you're going to have to do both. Classify it by its sides, classify it by its angles. Now, when it comes to angles, the book will say, measure each angle to classify it. Sit up. I'm not going to ask you. Heads up off this. The book will say measure the angles. I'm not going to have you measure the angles. Just give me your best guess if they ask you for that. Now, the one thing I will say about classifying with the angles, if it's a triangle, it looks like this. And you might say, yeah, it looks like a right triangle. The way you can check it out is by taking the corner of a piece of paper, and I think we talked about this earlier this year. Take the corner of the piece of paper and try to match it up in there and see if it's a right angle or not. So use a corner of a piece of paper to see if it's a right triangle. If we're talking about the sides of a triangle, 3 ways to name it according to its sides. Scalene, which means no sides are the same. We don't use scalene triangles a whole lot because if no sides are the same, then you don't know a whole lot of information about it. Isosceles triangle. An isosceles triangle, at least 2 sides are the same. Might want to draw a picture of each one of these out here beside it. Isosceles triangle looks something like that. Those 2 sides are the same. Now notice on isosceles it says at least 2 sides are the same. So what's that telling you?
2, 3, 7.
It could be all 3. So all isosceles triangles are also equilateral triangles. So if there's a triangle that's isosceles, no, I'm saying that backwards. All equilateral triangles are also isosceles triangles. Equilateral triangle looks like this. Instead of just having 2 sides marked equal, it's got 3 sides marked equal. So if you're trying to classify the triangle according to its sides, 3 different names you could give it: scalene, isosceles, equilateral. If you're trying to classify it by its angles, according to its angles. An acute triangle, all 3 angles are acute. So what's that mean? All 3 angles are what? Less than 90, good. Less than 90. Might want to write that down there to make sure you remember what acute means. All 3 angles have to be less than 90 degrees. An obtuse triangle. An obtuse triangle has exactly 1 obtuse angle. How come exactly 1 and not all 3 like on acute? Alright, if I drew an acute angle there, and then I tried to make another, an obtuse angle, and I tried to make another obtuse angle, is it ever going to form a triangle? So to be an obtuse triangle, it has to have 1 obtuse angle. So if I tell you one of the angles in a triangle is 100 degrees, can the other angles be 100 degrees? No, it's not possible. Right triangle. How many right angles can a triangle have? 1. Can't have 2 right angles. If I draw a right angle and then I try to draw another right angle, is it ever going to make a triangle? Equiangular. This is probably new. Probably heard of equilateral before, where all 3 sides are the same. Equiangular, all 3 angles are the same. Now, in an equilateral or equiangular triangle, what's gonna happen, and we're gonna talk about this later, if I tell you all three sides in this triangle are the same, guess what's true about all three angles?
They're all the same.
They're all the same also. And if all three of those angles are the same, we're gonna learn a theorem here in a minute that you probably already know, Curtis probably knows it too. All three angles of a triangle have to add up to be how much? 180. Right? And if all three of these are the same and they add up to 180, could we figure out how much each one of them is? And that's what I put right here. In an equilateral or equiangular triangle, every angle has to be 60 degrees. Guarantee on the next test, there's going to be a problem that says this. Triangle ABC is equilateral. Find the measure of angle A. And I'm not going to draw a picture for you. It's just going to say that. Because you should know as soon as I tell you that that triangle is equilateral, that every angle is how much? 60 degrees. You've got to make sure that you understand that. Caleb, does that make sense? Triangle's equilateral. What do you know about each angle? Every one of them's the same and they're all 60 degrees. Now, does that work for an isosceles triangle? No. Does it work for any of these other triangles? No. Just equilateral or equiangular. All right, write these three things down. A corollary. I put corollary on here. Bree's going to do this. She's going to sort of mark out corollary because we don't want to learn about corollaries. At the start of the year, I told you anytime you've seen corollary, treat it like it's a what? Postulate. Just think of it as a postulate. Postulates and corollaries are basically the same thing, and we don't want to learn two different terms that mean the same thing. It's too much for Austin to try to fit in his head. Right, Austin? As you're writing this down, somebody tell me about that question mark right there. What's it going to be? 30. How did you get that? So if you know two angles of a triangle, you can always find the third by adding these two angles, then subtracting from 180. 180 minus whatever you get there, and that's going to tell you the third angle. That should be one of the easiest things that we cover today. You should be able to do that. If you know two angles of a triangle, you can always find the third angle. Get to this last one, you get to this corollary. What's complementary mean again?
180. Or 90.
90. We need to probably have another definitions test here pretty soon, don't we? Theorem 5.2 is probably the hardest one. Everybody has trouble with that. This book explains it a little different, so maybe it'll make it easier. What's non-adjacent mean? If things are adjacent, what's that tell you?
The 9.
Adjacent. Whose room is adjacent to this room?
That guy.
Alexander.
Mr. Alexander's room. All right, so those are adjacent. Adjacent means hooked to, right? Like neighbors. Non-adjacent then means what?
They're not neighbors.
They're not neighbors, all right? Not hooked together. When all the other books I've ever taught it out of, and somebody probably figured out, hey, these terms confuse people, because they always did. Remote interior angles. first of all, what's an interior angle tell you? It's on the inside of the triangle. And remote means away from. If you're on a remote island, then that means you're away from everything else. When you're using a remote control, why is it called a remote control?
You can push the buttons away.
You can push the buttons and change the channels and everything away from the TV. You don't have to be right up on it. Alright? You guys are all too young, but when I was growing up, you had to actually go up and use the knobs on the TV to change the channels.
My granny had one of those old TVs. She's like, go change the channel.
So most of you are, too young. You never, everything had a remote control by the time that you were around. But my mom and dad did the same thing. Go change the channel. Go up there and change the channel. Wasn't none of this flipping through and flipping around to see what you wanted to watch. You got it somewhere, and you usually just stayed there and said, "The heck with it. We'll watch whatever's on this channel." So remote interior angles. If I'm looking at this, and we're going to do this here in a second. If I label these 1, 2, 3, and angle 4 out here. Angle 4 is an exterior angle. How come it's called an exterior angle? It's on the outside. You see that, Caleb? See how angle 4 is on the outside? Forget that stray mark there. See how angle 4 is on the outside of the triangle? It's an exterior angle. Right? 1, 2, and 3 are interior angles. The remote interior angles are the two angles that are away from it, or not adjacent to it, not hooked to it. Which angle is hooked to angle 4? Curtis, which angle is hooked to angle 4? Angle 3. So which two angles are not hooked to angle 4? Those are the two that this theorem right here tells us. Those two added together got to equal that exterior angle. These two added together have to equal that angle. Not the numbers, but whatever the angles are. So let's go back up here. If I do this and I draw that, this is an exterior angle, right? So what's that exterior angle got to be in this triangle? We take these two. The interior angle has to be 30. Take these two, add them together, and that gives you the exterior angle. So it's 150. Well, what should be true about these two angles right here? What should be true about that 30-degree angle that you guys told me earlier? They should be supplementary. What is 30 plus 150? 180. Works out. All right? So maybe Austin F sitting back here, he never ever wants to use this theorem. Because he doesn't like exterior angles. They don't make any sense to him. So could he figure out this angle is 70, this angle is 60. Could he then figure out angle 3 down here? Yeah, 70 plus 60 is 130. Subtract that from 180. What's angle 3 then? 50. Then could he figure out what angle 4 is? Yeah, because 3 and 4 have to add up to be how much? 180. So what is angle 4 then? 130, is that right? What's 70 plus 60?
130.
130. It's the same thing either way. So several different ways you could find it. Alright, I want you to write these two down, draw these pictures. As soon as I get my stuff out of the way here, but I'm changing my ink color. It'll let me. There it goes. So draw this, draw those pictures. I'll give you a minute. Skip a little space in between each one. Doesn't have to be a whole lot of space. How are we gonna find the measure of angle A? Does everybody remember? How's this red right here? Measure of angle A. How are we gonna find the measure of angle A in that first example? So 112, that's one of the interior angles, plus 34. Bree might have to get her calculator out if she doesn't like writing stuff down, right? 6.
4.
Then what do we do with that?
Subtract from 180.
Subtract it from 180,
34.
and then that's when you grab your calculator, right? Borrow, make sure if you're borrowing here, if you're doing out longhand, what's 10 minus 6?
4.
7 minus 4?
3.
1 minus 1?
0.
So what's the measure of angle A?
34 degrees.
34 degrees. Don't make those problems harder than they are, should be pretty easy. You know, 2 angles of a triangle, should be able to find the third angle. Could we do the same thing on this one?
Yeah.
Yeah, now what that corollary told us on this one was instead of doing that, and this will make Curtis happy, we can do it using less work. If this is a right triangle, then these other 2 angles have to add up to be how much? 90. So instead of going through all this and adding those 2 and then subtracting from 180, we know that angle A and angle B should add up to be 90. So how could I find angle A then?
90 by 67.
90 minus 67, and we just have to do one step, make it a little easier on ourselves. 3, that's 8, what's 8 minus 6?
2.
So what's the measure of angle A in that one?
23 degrees.
Now Caleb remembers absolutely none of that I just said. Could he add these 2 together and then subtract from 180 like we did on that first one and get the same answer? Yeah. He just has to remember that little box tells him what? 90 degrees. Next one, draw this picture and write these 3 things down. This goes with, what was that, theorem 5.2? Theorem 5.2, I think. Is that the one that dealt with the exterior angles? Very important that you understand this as we go through it. It's not hard. So even though Lexi thinks that she can't learn all this stuff, don't make this harder than it is. It's pretty easy stuff. As you're writing it down, which angles are interior angles in this picture? 4, 5, and 6. Which angles are exterior angles? 1, 3, and 2. Now they're going to try to confuse you on some pictures because they're going to do something like this, draw something like that, then they'll have another triangle here, and then you're going to be looking at angle 1 right here, and they're going to say, is that an interior or exterior angle? Well, for one triangle it's an interior angle, for the other triangle it's a exterior angle. So you got to be able to pick that out. The interior angles of a triangle, we said they always add up to be how much? 180. The exterior angles, and this isn't just for a triangle, this is for any shape, and we're going to learn that later on in the year. The exterior angles of any shape in the world always add up to be 360 degrees. Caleb's going, how can that be? A triangle, how many exterior angles does a triangle have? 3. How many exterior angles is a pentagon going to have? 5. So since there's more angles, shouldn't it add up to be more? Doesn't work that way. All right? Exterior angles of any shape is always going to add up to 360. With exterior angles, there can only be one exterior angle at each vertex, at each vertex, so at each point. So here I have angle 1 here. All to make an exterior angle, all you have to do, and mine's crooked, but you're extending one of the sides straight out to make an exterior angle. Well, Caleb comes up here and he says, well, that was stupid. Why'd you extend that side straight out? Why didn't you extend this side straight out? Is this an exterior angle then? Yeah, but what's true about this angle and angle 1 right there. They should be the same. What kind of angles are they? We covered this earlier in the year. They're vertical angles. Gotta remember vertical angles, because that's gonna be real helpful in a lot of the stuff we do. They're vertical angles, and vertical angles always have to be congruent to each other. Vertical angles must always be congruent. Alright, next thing, write this down. We're gonna do this together. Give you a minute to write this example down.
Same picture.
And basically, yeah. Hang on. Is it gonna hurt you to draw three more segments? If your hand falls off, we'll glue it back on for you. Curtis, you help me glue his hand back on, wouldn't you?
Probably not. Just because it's heavy.
What was it?
Yeah, I know he said the same thing, because it sounded like he said your name, and he knows that that's not
Yeah.
allowed.
That's his name.
Okay, so let's just make sure. Theorem 5.2 said the two non-adjacent interior angles must add up to equal the exterior angle. And I've got these sort of backwards. The first three are backwards and the other three are the other direction. I'm looking at angle 1 here. Which two interior angles are the ones that are not adjacent to, not hooked to angle 1?
Two.
Which two interior angles? Help me out here,
5 and 6.
Kenneth. Which ones are not hooked to angle 1? I'm gonna start calling on people. So you better be paying attention. And which two interior angles? 5 and 6. So angle 5 plus angle 6 has got to equal angle 1. Alright? Angle 2. Ready back there, Hannah? Angle 2. That's right here. Which two interior angles have to, or are not hooked to angle 2? So fill that in your blank. Angle 4 plus angle 6 should equal angle 2. Ready, Lexi? Angle 3, that's right here. Which two interior angles have to add up to equal angle 3? Which two are not hooked to angle 3? Angle 4, that's one of them. 5. These two angles that are not hooked right there to it, those two have to add up to be whatever that exterior angle is away from it. Looking down here, all right, Chloe, angle 6 plus angle 3. What do we know about angle 6 and angle 3? They got to add up to be how much?
180.
Write that in, fill it in. Those two have to be supplementary. How about angle 1 and angle 4? Anybody?
Wait.
How about angle 2 and angle 5? 180. Remember, they make a line together. They're called a linear pair. We talked about that earlier in the year. Please don't think, do 2, 5, and 6 all make a line together? No, they're completely different vertices. They're at different corners, so they can't add those all up like that. How about 1, 4, 6, and 3? They all add up to 180? No. All right. Let's just do this one real quick. I won't make you write it down if everybody's paying attention and setting up right now. Measure of angle JLK. Somebody come up and show me where angle JLK is.
Oh.
No.
You said do what?
JLK.
We have to go up
Get
there.
on that.
Just trace it for me. Trace angle JLK.
Get on that.
Hurry up.
It's right
I don't
there.
know why they're laughing at you, because they're gonna be up here in a second.
Yes. Yes.
J.
Yes. Yes.
No stuff with K.
That's the whole triangle. Trace, stay up here. Trace angle
I know,
J.
right?
Literally just.
Trace angle JLK.
No,
That's right.
like a line,
What
like
is
trace
this?
a line.
Start at J.
I don't know what trace
Get on
is.
the line.
Oh,
Yeah.
okay, I got you. It stopped working.
Do you see that angle that you just traced?
Yeah. Don't stop making me get up there, dude.
It's this angle right here.
Messed it up.
So angle JLK is 78 degrees, so we write that in there. 78 degrees. Measure of angle LJK. LJK is 65 degrees. Austin's going to trace angle LJK for us. Everybody agree with that one?
Yeah.
Alright, so we know that that angle's 65 degrees. We want to find the measure of angle JKM. JKM is this angle right here. How could we find that angle?
Two.
It's obtuse angle, but we want to know the actual measure of it.
Oh. 78, 65.
We could add these two together, subtract from 180.
Yep.
That's going to give us this angle. And then subtract that from 180 to get that angle out there, right? Is there an easier way? What kind of angle is this one out here?
Obtuse.
That's true, but it's also a exterior angle that we just got done talking about.
Yeah, 360.
What should be true about these two?
One.
They should add up to equal that angle. So all we really got to do, you guys are saying, do this. This is what you guys told me to do. Add these two together. It's 143. And then you said subtract from 180.
Yeah.
And that'll give us this interior angle.
Yeah. And then you subtract.
And then you subtract that from 180 to get that exterior angle. Don't we already have the exterior angle? That's it right there. So this angle's 143 degrees. Now JKL is this angle. Now we can go back and subtract this from 180.
37.
And we get 37. So what's the measure of angle JKL?
37.
You guys you're doing an extra step if you don't use that exterior angle theorem. All right, now does it matter if you do that extra step? I don't care, because you're going to hopefully get the same answer. But if you make a mistake subtracting, then it'd mess everything up. We use the same picture. I'm going to redraw it down here. It's J, L, K, and M is out here. Angle JLK, Curtis already showed us that's that angle right there, right? It's 70 degrees. Angle LJK, Austin showed us that, and it says it's X degrees. Angle JKM is the exterior angle, is 2x minus 5. Could we set up an equation from all that information? This is where it's going to mess you guys up if you don't try to do stuff the right way. I'm serious, I won't ask again. If your eyes are closed or your head's laying down, it's going to be a detention. I'm not even going to mess with you guys the rest of the year. It's getting a little ridiculous. What did we just say about these two angles? They should add up to equal that exterior angle, right? So what equation could I set up here? This angle plus this angle, these two added together should equal that exterior angle, 2x minus 5. All we're going to do here, get all the x's on one side, so I'm going to subtract x. Hopefully you remember how to solve equations. 70 equals, what's 2x minus 1x? 1x minus 5 still. How do I get x by itself? Add 5, what's x end up equal? 75. So x equals 75. What they say, find all the angles in the diagram. So x is 75, so what's this angle right here? 75 degrees. Now, instead of plugging 75 back in here, because that Lexi's thinking, man, I don't know what 2 times 75 is. Could we add those two together, subtract from 180 and get this angle? 75 plus 70 is what? 75 plus 70?
145.
145. So what's the measure of this exterior angle out here?
145.
145 degrees. How can we get this angle?
Straight from 180.
Subtract that from 180. 180 minus
35.
145, which is 35. Did we find all the angles in the diagram, in the
Yep.
picture? But you gotta be able to go back and do that.
I'm not going to.
I'm not gonna mess with him closing his eyes. He better have his head up off his desk. So I'm done. On this one, draw this picture. We're not gonna discuss it in this class anymore. Your head's on your desk. I'm not gonna say, are you sleeping or not? It's just gonna be a detention. Nope, if your head's on your desk. I don't care if it's sideways.
This is trippy. Yeah, I got it.
These are the kind of pictures you gotta be able to do this. These are the kind of things I like because this shows me that you know all the rules about triangles and about supplementary angles and all the different things. Numbers in there.
Crap, I'm straight up there. Better get them dudes.
This is supposed to help you so that you maybe can understand some of it. Chloe, you still with me? Draw this picture? Why not?
She's a done. These streets of El Dorado.
I don't want to hear no more. We're done. Give me an angle, the first angle that we can find.
90 degrees.
Which angle's 90 degrees, Curtis?
That one right there.
Which one?
There. 2. Wait, no. I don't know. One across. Yeah. One across.
So that's 90 degrees, so we could write that in there. And that's all we're gonna do is write in this picture what each angle is. We know that's 90 degrees, we know this one over here is 90 also, right? These are the boxes. Now give me another angle that we can find.
1.
Angle 1. How can you find angle 1 down here?
90 plus 32.
Say it again.
90 plus 32.
Be careful now. Because this exterior angle is hooked to that 32. So these two won't add up to equal that.
Alright, so that'll be 148.
So 180 minus 32,
148.
148. Everybody agree with that? So angle 1's 148. We can find that because those two have to be supplementary to each other. Give me another angle we can find.
2.
Angle 2, how you gonna find it? Say it again. 90 and 32. So if we add those two together, now there is an easier way to do it. We add those two together, we get what, 122, is that right? Does that mean angle 2 is 122? What do we have to do to find angle 2? Subtract it from 180. Those three angles of a triangle got to add up to 180. What's that give us?
38.
Don't sound right. 58.
What's the deal with that?
So angle 2 there, write it in, it's 58 degrees. Give me another angle we can find. Curtis, pick up your stuff. Yeah, well,
Yeah.
then ask me and I'll give you some. What do you know about angle 5? It's 58.
Berkeley.
They're vertical angles. Those two have to be exactly the same. Give me another. 7's gonna be 32. Everybody agree with that?
Shouldn't 8 be 140?
8. If we're looking at 8, if we look at these two right here, they should add up to give us angle 8, right? Is that what you just did? That's what it sounds like. So 90 plus 58 is how much? 148. another angle. 7 is 32.
Right.
So these three angles, these two and angle 7 should add up to be how much? 180, because they make a triangle. So that's 32. Give me another one.
3.
Angle 3. How are we gonna find it?
It's up there, right?
We could just do, these two have to be supplementary, right? So 180 minus 58, well, we did that over here somewhere.
122.
What is it?
122.
122. Angle 4 is 122. One more. How can we find angle 6?
58.
Do what?
Is it 58?
Is angle 6 gonna be 58? Everybody agree with that? It's an exterior angle, right?
Okay.
Which two angles in this triangle are not hooked to it?
5, 7,
So what could we do with those two? Add them together,
90.
and it ends up being what? 90. Now, could we have just looked at these two and said that those two have to add up to be 180 because together they form a line? Yeah. So you should be able to find all those. Give them a picture like that. Nothing really difficult there. You just got to use all these rules and go a little bit at a time. All right, write this down. Isosceles triangle. Draw that picture. Got to know all these parts to an isosceles triangle. If you don't know the parts of the isosceles triangle, you won't be able to do what you're supposed to do with when they say this triangle is isosceles. You gotta, because whenever they give you an isosceles triangle, you gotta know where the legs are, where the base angles are, where the vertex angle is, where the base is. Because they're gonna tell you one of those parts, so you know that. Isosceles triangles don't always have to look like this. Is this triangle here still isosceles? Yeah, even though it's laying down sideways. Is the base always on the bottom of an isosceles triangle? No. What's these marks tell us about these two legs here?
They're the same.
They're always the same. That's telling us that they're congruent. Down here at the bottom, when you get to this, the base angles. What's it say about the base angles?
They're always congruent.
They're always congruent. So you could draw in those two little arcs to show that those two angles always have to be congruent in an isosceles triangle. The legs always have to be the same. The the base angles always have to be the same. So if I gave you an isosceles triangle, I told you this triangle was isosceles, and we call it QRM. Told you these two sides are congruent. I told you this angle right here was 50 degrees. Could you find the other angles in the picture? What other angle has to be 50 degrees also? Angle M has to be 50, so we could find that because the base angles always have to be the same. Could we find angle Q? What do you know about the three angles of a triangle?
Same.
They got to add up to equal 180.
So
If that's 50, if that's 50,
80.
how much is left over for that one? 80. So they gave us one piece of information and we could find a whole bunch of other stuff. Isosceles triangles and equilateral triangles very important because they do tell you so much information. Again, as much as Caleb hates drawing all these pictures, make sure you draw that picture the way I have it drawn up there so you can look at it and say, okay, in an isosceles triangle, I know all this information. Base.
Alright, guys.
two things down. These are two theorems. These are the shortened ways to say these theorems. Theorem 5, 6. And when we go to prove things or do whatever, write it down this way. Don't write it down out the long way like the book's going to have you doing. And don't write theorem 5.6. We know that, right? Because I mark that wrong every time. If, what's this first triangle telling us? The triangle has what?
Two same legs.
Two sides congruent. Then we know what? The angles, the base angles are congruent. That's all it says. If two sides in a triangle are congruent, then the angles across from them have to be congruent. What's this one say? Two angles. So if I gave you this, we'll call it ABC. And I told you these two angles are congruent. What else can you tell me in that picture? Which two? Segment AB has to be congruent to segment AC. Very good. And the way I always do it, anytime I see an isosceles triangle where I know two angles are congruent or two sides are congruent, I do this. I draw in these arrows. This angle is opposite this side. That means that side has to be one of the congruent ones. That segment or that side is opposite this angle, so that has to be the other one that's congruent to. Two theorems, real easy. If sides are congruent, then the angles have to be congruent. If angles are congruent, then the sides have to be congruent. Caleb, you can handle that? I always, if it's isosceles triangle, I always draw in those arrows just to help me out. Equilateral triangle. Draw this. Two corollaries that go with equilateral triangle. What's it mean to be equilateral? First of all the sides are equal. So if I did this,
Then all the angles.
all right? And what this corollary is saying, if all the sides are equal, then what do we know about all the angles, Curtis? All the angles are equal. So if you see an equilateral triangle, then you know all three angles are the same too. And then the other corollary, again, not too much concerned about corollaries and stuff, but we're not going to learn what a corollary is. Does anybody remember what a postulate is? Something that we what?
Is it like always true?
Yeah, it's sort of. We take it for granted to be true. A theorem is something that we have to prove is true. Corollaries are like postulates. We just take it for granted it's true. Because Mr. Eversole told us.
Why do you need two names for something?
I have no idea. I understand. That's why I didn't get all too upset about it. Key thing down here at the bottom. If we know this triangle's equilateral or equiangular, all angles equal what?
60 degrees.
60 degrees. You've got to know that. That's a very, very key thing. If it's an equilateral triangle or equiangular triangle, every angle every single time is going to be 60 degrees. Every time they're going to be 60 degrees. Bree, this is all easier stuff, right? Than all that stuff we've been doing the last couple of chapters. This is all stuff that you'll be able to handle. A piece of cake, right? We're looking at this. Number one here. Tell me the length of this side. 12 feet. How about the length of this side? 12 feet. How about this angle right here? You guys forgot it already. Thank you, Chloe. Say it. 60 degrees. How about this angle? 60 degrees. Did they have to tell us anything about the angles so that we could find them? What's this angle? 60 degrees. Let's jump down here. What do we know about all three of these sides?
60 degrees.
What do we know about all three of these sides?
All the same.
They're all the same. What do we know about angle M?
60 degrees.
60 degrees. We can just fill in the angles. They all have to be 60. Now, how could we find the sides in this case?
3x plus 3 equals 4x minus 2.
If all the sides are equal, then this side should equal that side. Now, what's going to confuse you is if they throw in some other thing down here for this one, you're going to say, well, which two do I pick? Does it matter which two you pick? We solve this, x equals 5. How am I going to find the length of the sides if x equals 5? Does that mean each side's 5?
Oh no.
No, you have to put it in 5.
Plug it back in. What's 4 times 5?
20.
20 minus 2?
18.
18. What's this other side over here then? 18. Now they didn't tell us nothing about this side, but how long is it?
18.
18. All right, that's your assignment. What do we got? 3 minutes?
Ah.
We're supposed to have more time than this. Write this down. 'Cause I was going to do a whole bunch of your assignment for you, but
Well, I got you.
so it's on 2 pages. 230. Hold on, one of those pages is wrong. Big dummy me. I know. Don't write down that second one. I must have lazy and copied and pasted. Wait a second, and I'll put the other one up there.
Maybe because you get that term from Adam. But look.
That's what it is.
I do the modifications for A ball.
I do.
I got that matter of money.
I'm deleting that one.
I deleted the 8-ball pool because it kept bringing
I don't think
I was like, no, you're not bad.
I mean, when it says I'm on mine, you get home there and I'm on mine, I take it.
I just put
I deleted it, I was like,
I just started with that daily rewards.
So you're texting?
Yeah. you can,
I'll smoke you them up again.
I played Battleship.
don't know about that.
Like,
What cheating app?
I haven't heard of
on the app.
it.
Hey, Kenny.
Ooh, I
You
think
could,
it
like,
was calm too.
be like.
All right, there it is. That's the right one.
That's your credit
I
card?
thought you were too.
Ah, hold on.
Where'd it go? Can't see
No, it's still-
I don't know. I'm trying to figure out did I do it.
What?
No, I got it.
Press sit down.
It's probably the starter for
Make sure you got that written down.
Guess who's playing A ball pool? Billy Hall.
Nathan's gonna remind me during the
It's
day.
healthy.
I'll play you in intervention. Don't do it. Come on.
You gotta get on Madden Mode and daily rewards every day. That's all I do anymore.
Daily rewards.
All right, so look at page 236 first. We'll do some of these problems together. Problem number 1 on 236 says, can a right triangle also be obtuse? Explain your reasoning. No. If you had an obtuse angle, plus a right angle, which is 90 degrees, that's going to add up to more than 180. And the 3 angles of a triangle always got to add up to be 180 degrees. Number 3, identify the triangle by its sides and by measuring its angles. I don't care, again, I don't want you to measure its angles, just want you to give your best guess. So on number 3,
Hey, Jack.
yep, I'm in here, come on in. Number 3, we want to classify it according to its sides first. Well, these tell us that these 2 sides are congruent, so if it's got 2 sides congruent, then it's an isosceles triangle. And then we see this box down here, according to its angles then, it has to be a right triangle. So it's an isosceles triangle and a right triangle. Number 4, these tell us that all 3 sides are congruent, so it's equilateral. Well, if it's equilateral, then that means it's also got to be equiangular. And again, I'm not going by spelling because I probably spelled a couple of these words wrong. We look at number 5. On number 5, looking at it according to its sides, we don't have any markings where any of the sides are congruent, so I'm guessing that that is a scalene triangle. We look at the angles. Looks like this angle right here, more than 90 degrees, so it's going to be according to its angles. The name that we give it is an obtuse triangle. Number 6 says check with paper. You take a piece of paper, lay it right here in that corner to see if that is a right angle or not, using the corner of a piece of paper. That's the best way to check it. I lay my piece of paper in there, and it looks like the corner of the paper matches up perfectly, so we're going to say it's a right triangle according to its angles. I named it wrong. We should have said this is according to its angles. And we look at the 3 sides. Looks like all 3 sides are different lengths, so it's also a scalene triangle according to its sides. Number 7, still on page 236, number 7. Says, in exercise 7 through 10, classify triangle ABC by its sides, then determine whether it is a right triangle. So on number 7, I'm going to graph it real quick. Number 7, I've graphed this triangle. We had, this point was 2, 3. This point was 7, 3, or 2, 7. And this point was 1, 2, 3, 6, 2. Or 6, 3, sorry. I have to look at the book and see. 6, 3. Right away, we look at this side, and it's a vertical segment. We look at this side, it's a horizontal segment, and where those two come together, anytime a vertical and horizontal line meet, they're going to form a right triangle. So on number 7, it's a right triangle. We know that. Now to find the lengths of the sides, and this, since this is a horizontal, all we really got to do, we don't have to use the distance formula to find the length of them. We just got to count. That's 4, so that side's 4. Over here, this vertical segment, all we got to do is count. That side's 4. In a right triangle, the hypotenuse is never going to be the same length as the other 2 sides. It's always going to be the longest side, so it can't be 4. But we do know that these 2 sides are 4, so we know that number 7, it's got to be an isosceles triangle. Isosceles triangle. Number 8. Give me a second to graph number 8. Number 8, the triangle looks like this. To find what we want to find about all this, things you need to remember: distance formula. Got to be able to use the distance formula, and you got to be able to use slope. Find the slope of each thing. On this, first thing I'm going to do on each one is I'm going to find the slope. Once we find the slopes, we'll be able to tell if it's a right triangle or not. So if I do the slope for this side, for AC, I'm just going to count rise over run. So I can go up 1, 2, 3, 4, 5, 6, up 6, over 1, 2, 3. So slope of that one right there is 6 over to the left, -3. So 6 over negative 3, which reduces down to negative 2 over 1, and we'll worry about that here in a minute. I'm going to find the slope of this one, BA, go up 1, 2, 3, 4, 5, 6, and I go to the right 3. So 6, 3, that reduces down to 2. You got to be careful. If these two slopes are opposite reciprocals of each other, then this would be a right angle. 6 over negative 3 and 6 over 3 are opposites of each other, but they're not reciprocals of each other. So that's, this angle right here is not a right angle. And it actually, we can sort of tell that it looks like it's going to be an obtuse angle. We could find the slope of the other one just to make sure that angle B or angle C aren't right angles. For it goes from 6, negative 3 to 6, 9. Well, you just go up 12 and you go left or right 0, so it's 12 over 0. Well, that's a vertical segment, so it doesn't actually have a slope. So it can't be perpendicular. It can't form a right angle with either of the other two sides. So in number 8, we know it's not a right triangle. Now the other thing that we're going to do to figure out the sides is use the distance formula. We don't have to use the distance formula on this side because we already figured out it's vertical. All we got to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So length of that side is 12. To find the length of the other two sides, we got to use the distance formula. And I'm going to just set it up out here, then I'll do a lot of it in my head. You subtract the x's. So 3 minus 6, if we're doing AB, 3 minus 6 squared plus, then you do the y's, which is 3 minus 9 squared. You do a lot of this in your head. 3 minus 6 is negative 3. Negative 3 squared is 9. 3 minus 9 is negative 6. Negative 6 squared is 36. 36 plus 9 is 45. 45 is not a perfect square number. We could break that down and stuff, but I'm just going to leave it that way for now. So length of segment AB is the square root of 45. Well, the length of the other one should come out to be the square root of 45 also, which is AC over here. We're going to set it up. We got 3 minus 6 squared for your x's, and then 3 minus a negative 6 for your y's. 3 minus a negative 3 for your y's. That's a negative 3 there. 3 minus 6 is negative 3. Negative 3 squared is 9. 3, and we can change these signs to plus. 3 plus 3 is 6. 6 squared is 36. Add those together, and you get the length of segment AC is also the square root of 45, whatever that is. And you can do it on your calculator if you want, but just looking here, that tells us that those two are the same, and it's not the same as this 12. So we know that this triangle has two sides that are the same, so it is an isosceles triangle. So it's not a right triangle, and it's an isosceles triangle. That should be your answer right there for number 8. Number 11, find the measure of angle 1. All we're going to do on this one, 3 angles of a triangle should add up to 180. So we take 78 plus 31, add them together, you get 109. Then you subtract that from 180. Use your calculator. It's 17. So the measure of angle 1 is 71 degrees. Same thing on number 12. Add these two up. 30 plus 40, 70. Subtract that from 180. Please make sure you use your calculators so you don't make a careless mistake. So angle 1 here is 110 degrees. Number 13, This tells us it's a right triangle, so these other two angles, this one and this one, should add up to 90. So all we actually gotta do is take 90 minus the one angle we know, which is 38. Borrow there, get 52 degrees. So angle 1 is 52 degrees. Looking at this next one, this angle 60, this angle 60, the only way that can work out is if angle 1 is also 60. It's gotta be an equilateral triangle. Number 15. We had a theorem that said this exterior angle, that's an exterior angle, is going to be equal to the two non-adjacent interior angles. The non-adjacent means the angles that aren't hooked to it. That right there is the angle that's hooked to the exterior angle. So these are the two non-adjacent. And all we got to do is add those two up, and that's going to give us that exterior angle. That's 139, so the measure of angle 2 right there is 139 degrees. Let me read the directions here, make sure I didn't mess up on 15. What's it say? Find the measure of the exterior angle. So that's all we were doing on that, was finding that 139 degrees. 17, we're doing the same thing. We're going to end up finding the measure of that. These two angles added together should equal this angle, so that's the equation we're going to set up. 2x plus 18 plus this 24-degree angle up there should equal this exterior angle, which is 3x plus 6. We solve, collect like terms right here. It's going to give us 2x plus 42 equals 3x plus 6. Subtract 2x on both sides. Oops, 2x over there. These cancel out, you're left with 42 equals x plus 6. Subtract 6 on both sides, and you're left with x equals 36. They didn't ask us to find x, they asked us to find this exterior angle right here. All we got to do then is plug in x. So you take 3 times the x, 3 times 36, plus 6. Do the math. 36 times 3, 18, that's 9, 10, 108, then add 6 onto that. So that exterior angle is 114 degrees. That's your answer for number 17. Number 19. Number 19 on 19 through 22, they want you to find the measure of each acute angle. So they want you to find the measure of each of the two acute angles. Well, we know that this is a right angle. That's what that box tells us. These two angles got to add up to 90. So 3x plus 2x should equal 90. 3x and 2x give you 5x equals 90. Divide both sides by 5. Take your calculator. Divide 90 by 5. Comes out to be 18. Now we don't want x, we want the angles. So we plug them back in. Plug in here, 2 times 18 is 36 degrees, so that's one of our answers. Then we plug back in here, 3 times 18, 18 times 3 is 24, 54 degrees. And we could check our answer to make sure by adding these two together, they should add up to be 90, which 54 and 36 do. Again, same thing on this one. This is a right angle. So this angle and this angle should add up to be 90. So 3x plus 2 plus this angle, which is x, should equal 90. Like terms. 4x plus 2 equals 90. Subtract 2 on both sides. Get 88 equals 4x. Divide by 4. X equals 22. Plug back in, that tells us this angle right here is 22 degrees. We plug in over here, 3 times 22 is 66. 66 plus 2 is 68 degrees. So that other angle is 68. And again, we could check it by adding those two up, and they should add up to be 90, which they do. 23. In a right triangle, the measure of one acute angle is 5 times the measure of the other acute angle. Find both acute angles. First thing you should do on this, we did some problems like this earlier in this year. Right, first angle, second angle. First angle, we're just going to let it equal something. When we don't know what it is, we'll let it equal x. Well, they tell us that the other angle is 5 times the measure of the other. So if this one's x, then this one's going to be 5 times x. They told us this was a right triangle, so the two acute angles got to add up to 90. So x plus 5x should equal 90. 6x equals 90. Divide by 6. End up with x equals, 6 will go into 90. 6 will go 9 once. 6, subtract, you get 30. 5. So 15, so x equals 15. Now we wanted to find both angles. When we come back over here, then the first angle is 15 degrees. And the other one is 5 times 15, which is 75 degrees. So those are our two answers. This one I added on because I like these kind of problems, and I didn't see any in the book on this page, and I just wanted to throw one in. Says the three angles of a triangle are at a ratio
Mr. McKnight,
of
could
3,
you
6
please
to
call
9.
extension 13?
Three angles in a triangle are at a ratio of 3 to 6 to 9. When we draw this triangle, this angle's not 3, this angle's 6, and this angle's 9, because that doesn't add up to 180. What you have to do anytime you see a ratio like that is put a variable with each one of those numbers. So instead of this angle just being 3, it's actually 3x. This angle is 6x. This angle is 9x. And we know the three angles got to add up to 180, so we just set up an equation. 3x plus 6x plus 9x, those three add together should equal 180. Collect like terms, you get 18x equals 180. Divide by 18, you end up with x equals 10. Anytime you see this, that's what you're going to do. You're going to put a variable with each of those numbers and stick them into the angles, not just those numbers. Now it said find all three angles. Well, we got to go back and plug in. 3 times 10 right here is 30 degrees. So one of the angles is 30 degrees. 6 times 10 for one of the other angles is 60 degrees. 9 times 10 is 90 degrees. So those are the three angles. Those are the three answers that they want. Page 256. Flip over to page 256. On page 256, the first few problems there are dealing with that diagram. And you got to figure out which isosceles triangle you're dealing with. Here they tell us that segment AE, so segment AE, which is right here, is the same length as segment DE, which is right here. So we sort of want to get rid of those two segments, like they're not even there. And then we can figure out the angles. Again, anytime I'm looking at an isosceles triangle, I like to draw in these arrows. This side is across from this angle. This side is across from that angle. So those are the two angles that are going to be congruent. So in this case, we can name each of those with just one letter. So it's angle A is congruent to angle D. Next one, this time they tell us angles. They say angle D is congruent to angle CED. Remember angle CED goes here. So that's that angle. So we don't even care about the rest of this stuff over here this time. We just care about that part right there. Well, if those two angles are congruent, and my picture might not look like it, but then we draw in these arrows, the sides across from those angles have to be congruent. So the first side is this side, segment CD has to be congruent to segment EC. gotta be able to split stuff apart like that and look at it. You can't look at the whole one picture, you end up getting confused. And again, my picture doesn't look right, but the one in the book probably looks a little better. Next, they want us to find X on this. When we look at these angles and they're all congruent, that means it's an equiangular triangle. Well, if it's equiangular, that means it's also equilateral. X is right here. We know this side is 12. On the equilateral triangle, all of them got to be the same, so X equals 12. Next one, this is an equilateral triangle. Well, if it's equilateral, we also know that all the angles are congruent. And if all the angles are congruent, then all of them have to be 60 degrees. So this time that X right there has to be 60. Next one says find X and Y. When you get a picture like this, I'd split off. I look at this triangle right here. I know quite a bit of information about it, so I'm just going to split it off. I know this side's 40. I know this is 8y over here. I know that all these angles are congruent to each other in this triangle. Well, if all those angles are congruent, then that means all these sides are congruent. Well, then these two have to be equal to each other, so 8y has to equal 40. Divide by 8. And you end up with y equals 5. So that's half our answer. We still got to find X. We look at, let's see, what could we find out here? We know that this angle's 60 degrees. We know this angle's 60 degrees. I'm sort of trying to figure out stuff here, and I don't know exactly what I'm doing, so I look at those, and I see, okay, that's 60, that's 60, that's 60. We know this side's 40. We know that this segment over here has to be 40. Well, then if I look at this triangle, I know that this side's 40. I know that this side's 40. This is the X that we're looking for. We don't know for sure that this bottom side is 40. So we don't know that this is 40. But we do know that this triangle's at least isosceles because these two sides are congruent. We can find this angle right here because these two angles have to add up to 180. So 180 minus 60 is 120. So this angle has to be 120. And then we can find these other two angles because in an isosceles triangle, these two base angles have to be congruent to each other. So if this part up here is 120, we take 180 minus 120, we get 60. Well, if these two base angles are congruent, we're just going to take that 60 and divide it by 2. So each one of them has to be 30 degrees. So X in this case is 30. So sometimes you just got to fill in stuff until you get to something, fill in all the stuff you know, then that'll lead you to what you're trying to find. Next one, we got this sandwich. It says find the perimeter of the triangle. Try to find the perimeter of this triangle. Let me look at this because I probably messed up the problem. Number 23. Alright, so on this one, I forgot to put in that these two angles are congruent to each other. This angle is congruent to that angle. So I went back and put it in there. And if those two angles are congruent, it's an isosceles triangle, and an isosceles triangle, the sides across from the congruent angles have to be congruent to each other. So we know that these two sides have to be the same or equal to each other. So 4x plus 1 has to equal x plus 4. When we solve that, subtract x on both sides, you end up with 3x plus 1 equals 4. These cancel out. Subtract 1. 3x equals 3, divide by 3, x equals 1. And then we just plug back in, put 1 in there, so the length of this side is 5. Plug 1 in there, 4 times 1 is 4, plus 1 is 5, so that side's 5. To find the perimeter, we just add up all the sides. So we know one of the sides is 5, another side's 5, another side's 7. We add all them up, and we end up with 17. And our units this time are inches. So the perimeter of the sandwich is 17 inches. And that's the end of it. Hopefully you can do the rest.